All right. So let's continue on here into our next page. So page 642, we'll continue on. So letter F here on the next page, I do want to talk about this. Okay, so the Highway Administration also plans to put an exit for Dakota Lane. Get it? We talked about Arthur Avenue, point A, Collingwood Road, point C, Briar Street, point B, and now we're talking about Dakota Lane, point D. Isn't that clever of them? All right, so Highway Administration also plans to put an exit for Dakota Lane at a point that divides the highway from Arthur Avenue to Collingwood Road in a ratio of 2 to 3. Okay, so notice this is slightly different. We're not saying that Dakota Lane is 2/3 of the distance. We're not saying it's 2/3 of the distance. We're saying where Dakota Lane is, it breaks up that total distance so that there's 2 parts on one side and 3 parts on the other side of Dakota Lane. Okay, 2 parts from Arthur Avenue to Dakota Lane, and then 3 parts from that Dakota Lane to Collingwood Road. Okay. And we want to identify where that mile marker number for Dakota Lane would be. So, in other words, from Arthur Avenue to Collingwood Road, we're going to have to go 2 parts in on 2 parts from this side and then 3 parts from this side. Okay? So how many total parts are we talking about here? 5 total parts, right? If we want the ratio to be 2 to the left, 3 to the right, we want 5 total parts. Okay? So we want to cover this distance. What was this total distance again? 30. We want to cover that in 5 parts. So how much is each part? 6, right? Yeah, so 2 parts plus 3 parts has to equal a total of 30. So it's 5x equals 30. And so x is 6. So an individual part is 6 units long. Okay? But we want to go 2 parts in from Arthur Avenue, right? Ratio of 2 to 3. So we want to go 2 parts in from Arthur Avenue, which means how far do we want to go from Arthur Avenue? I heard it 12. So we're going to go from A, go in 12. Okay, so 12 plus 14 is 26. So 21, 2, 3, 4, 5, 6. There is that Dakota Lane. Okay, so there's 12 in from there, 26, and then on this side, so I'll go from here to here. So that's 2 parts right there, or 12, and then from here to here, that is 3 parts, or 3 parts in this case would be 18. And it's got a location of 26 there. Okay, so slightly different ways that we describe these ratios. From A to C to find point B, we went 2/3 of the distance. So you could think of the ratio as 2 to 1, like this part B partitioned AC in the ratio of 2 to 1. Okay, whereas here for A to C, point D partitioned AC in 2 parts to 3 parts, 2 to 3 parts. But 2/3 of the distance means 3 is like the whole distance there. Okay, so helpful kind of like if you did those problems from yesterday where we were talking about like men and women and total people, similar kind of like ideas here. You want to make sure that you're matching up corresponding ratios and things. Okay. Okay. So let's take a look then at how we're going to do this now in something like the coordinate plane, which is 2-dimensional. 2-dimensional. Okay, so a directed line segment is a segment between 2 points, A and B, with a specified direction from A to B or from B to A. So it's kind of like a vertex, or sorry, not a vertex, a vector. Kind of like a vector in a way, okay? But it's just talking about it, it's a segment with a direction, that's all. To partition a directed line segment is to divide the directed line segment into 2 segments with a given ratio. Okay? So, here's an example of how we're going to do that. Here's our line segment, okay, AB. Okay, I'm going to tear these pages out, actually, so I can write on them easier. Excuse me. Ooh. Okay. So again, there's our line segment, AB, drawn right there for us. And the directions ask us to find the coordinates of the point P that divides the directed line segment from A to B in the given ratio. So again, A and B given to us there, and we want to divide that segment in a ratio of 3 parts to 1 part. Okay. Now, one option, and we're going to kind of we'll look over these directions that they use here, but we'll use kind of what we just did earlier. All right. We can see here that our graph, okay, runs from A to B, and it has a certain distance. All right. We want it to be such a way that there are 3 parts on one side of this graph to 1 part on the other side of this graph. Okay. So, in other words, how many total parts are we talking about here? If we want to put our point P so that there's 3 parts on one side, 1 part on the other side, how many total parts are we talking about? 4 total parts, right? Okay. So we're going to write a ratio that expresses the distance of point P along the segment from A to B. So point P is 3/4 of the distance from A to B, right? We're going to go 3 parts in from A towards B of the total 3/4. Okay. So we're going to go 3/4 of the total way from A to B. Okay. And then how do we do that, though, along a diagonal line like this? That's where it's a little bit tricky, right? We don't have this distance, right? I guess we could use a ruler and then do 3/4 of that and then measure that too. But we can actually do it more precisely using the rise and the run. Okay? Going 3/4 along this directed line segment is equivalent to going 3/4 of the run and then 3/4 of the rise. Okay? So we have to figure out what the run is here. That horizontal distance, so they calculate that for us, it's 16. They also calculate the rise for us, it's 12. So from here to here, that is 16. And from here to here, that is 12. Okay? I'm not going to jump to the next page because I'm going to lose my picture. Well, no, the picture is still there, I guess, if we do that. Okay? Of course, we're not interested in the total run or the total rise. We want to do 3/4 of those things. So you do 3/4 of 16 and 3/4 of 12. 3/4 of 16 is 12. Okay, so if you count 12 here, and be careful, these boxes are counting by 2s. So it'll be 2, 4, 6, 8, 10, 12. And then 3/4 of the rise, 3/4 of 12 is 9. So if you go up 9, it's going to go up 1. And then plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. Boom, there's where point P is going to be. Okay, so we go 3/4 of the 16, which is 12. And we go 3/4 of the rise of 12, which is 9. Okay? So right 12, up 9, and there's where point P is going to be right there. Okay? You add that amount to your x-coordinate for point P, -8 plus 12, and you add that amount to the y-coordinate of P. Okay, 9, add 9 to your y-coordinate of P. Sorry, add the 9 to your y-coordinate from A. So -7 plus 9 gets you to that point there. Okay, so the 12, add that to the -8 for A. The 9, add that to the -7 for A, and boom, you get your point P. Okay, question, Brandon?
I need to go for band.
Oh, okay, gotcha. Very good. Okay, the homework will be on Google Classroom, all right? Make sure we're doing everything on time there, too. Okay. Plenty of time. Okay, so let's try another one here. I got to still fix my clock. It's still an hour fast. I never fell back. All right. So, letter B, letter B. Let's take a look at this one. So this one, we're asked to plot these points, -4, 4. And letter B, 2, 1. Okay? And we'll connect those. I don't have my straight edge with me here, so I'll just kind of eyeball it. Actually, I can do it. Okay, there we go. So there's AB, and we want to find the point P, so that point P divides it in the ratio of 1 to 2. 1 to 2. One part on the left side, so one part between A and P, two parts from P to B. Okay? You might be able to eyeball where that's going to be. Can anyone like eyeball and see where that is going to be? All right. Madison, what do you want to say? Where would the point be? You want
starting at A.
Starting at A.
It would be
Negative 2, 3. Exactly right, Jackson. Is that what you're going to say too? Yeah. So it is. Very good. Okay, so sometimes you can kind of eyeball it and see. Yes. Since to get from A to B, we go down 1, right 2, down 1, right 2, down 1, right 2, 3 times, right? Well, there are your 3 parts. Down 1, right 2 gets us our first part, and then down 1, right 2, down 1, right 2 twice. There's our 2 parts on that side, and so that is where point P is going to be. But let's do it using the actual calculations too. So again, we're going to write a ratio that expresses the distance of point P along the segment from A to B. So from A to B, how many total parts are we talking about? If we want 1 part here and 2 parts here, how many total parts is that? 3. But from A to that P, how many parts from A to P? Just 1 part. So we're going 1/3 of the total distance here from A to B. Okay? We're going to break it up into 1 part on the left, 2 parts on the right, but it's a total distance, it's 1/3 of the total distance there. Okay? The run they already did for us. They took the x-coordinate of B, which is 2, and they subtracted the x-coordinate of A, which is -4. So in other words, this distance here, that distance right there is a distance of 6. What's the rise here? What's this rise? The total rise. -3. And we will use a negative. So it's -3. In other words, it's going to be, let's see here, 1 take away 4. So -3. Okay, you can count the rise if you want to, or you can calculate the rise. It's up to you. So point P is 1/3 of the distance from point A to point B. So 1/3 of the run, and we'll also do 1/3 of the, whoops, this is supposed to be of the, we'll leave this one run, I'll make this one, no, actually, I guess I should do run, and this one should be 1/3 of the rise. Right, they both had run, but one should be 1/3 of the run, one should be 1/3 of the rise. Okay, so 1/3 of the run equals 1/3 of 6, and what's 1/3 of 6? 2. And 1/3 of the rise is 1/3 of, we said the rise, remember, was -3. What's 1/3 of -3? -1. Okay? So instead of going the full down 3, right 6 to get from A to B, we're going to go down the ratio, the fraction, the proportional length of down 1 and right 2. Down 1 for the rise, right 2. So down 1, right 2, there's that point P again that we located. And again, you can find those by actually adding here. So the run is 2, so we'll take our A coordinate -4 and add 2 to it. So we get -2. We'll take the y coordinate of P, or to get the y coordinate of P, we'll take the y coordinate A, 4, and add our rise to it of -1, which gets us 3. And so there's the coordinate -2, 3 there. You have to go for the presentation stuff too. Okay. So again, the homework will be on Google Classroom. So -2, 3 there. Okay. All right. We'll skip the 3 about how in part A you use the distance formula, but I do want to talk about number 4 here. So number 4 says, what can you conclude about a point that partitions a segment in the ratio of 1 to 1? What's another name for that kind of point? The what? The midpoint. It's the midpoint, right? If you have one piece on one side and an equal piece on the other side, that point has to be in the middle. So it's the midpoint that you find. Okay, and then how can you find the coordinates of such a point? Well, that's easy. You just use the midpoint formula. Okay. All right. So for 5 and 6 here, you are given two scenarios. Okay, you can pick either one of those here. And I do have. Let's see. Do I have graph paper? I think I've got graph paper for everybody. Or I might just give you some graph paper to help you out with that, because otherwise it's going to be a challenge. Yeah. All right, so let me get you some graph paper here, and I can help you out with that. But I'm going to have you guys try like either 5 or 6 here and try and do one of those two. Okay, so immediately freeze that right there, and I'll get you some graph paper here. Well, actually, I'll just do this. I'll just do the whole sheet there. Okay, you're welcome. You can use this kind of help you answer one of those questions there. Okay, everyone else, you're on your own. So just, I'll get some graph. This graph paper, sorry, it's not quite as good, but it's better than that. This graph paper's not quite as good, but it's better than that. You're welcome. All right, so go ahead and give these a try here. I'm so sorry, Anna. I don't know why I do that. Thanks, Anna. You can just do one if you want. That's fine. I'll do both, but. Are you sure you use fresh batteries?
Yeah.
Yeah. So,
I've had it for like 10 years. It was my brother's.
nice. I think well, let me think. Possibly, but really, like, I feel like it shouldn't be the case because, like, you're just using, like, normal batteries, right? Like,
Yeah, they kind of also like treated that. So.
that is not good. Yeah, does that normally happen with batteries in there?
I think last time it happened too. But I think that.
Yeah, that is strange. Does it get jostled a lot?
Oh, okay. You're going now.
No.
I mean, it's like in a hot. I'm not sure if like.
Yeah, that's strange. Here back. Yeah, that shouldn't happen. Yeah.
My brother.
Nice. It's like a family heirloom now. You don't want to get rid of it, you know. It's like. I hear you. I had my graphing calculator that I had since middle school, but then someone stole it, so it was gone. It was a TI-83, not a plus, just a TI-83. Don't have it anymore. I was very sad. I had a racing sticker on it and stuff like that too. So sad. So sad. All right, so I'll go ahead and pop this up here. There's the answer for number 5, okay? That's the way to do it without using graph paper, all right? So again, I'll run you through the parts here, right? Seeing that our ratio, we want 5 parts to 3 parts, so 5 parts between A and P, 3 parts between P and B, right? We're going to have, A, then P, then B, and so there will be 5 parts between A and P, 3 parts between the P and the B there to create that ratio. So obviously P is going to be closer to B than A, okay, if that's the case. So what does that mean? Well, that means P is then 5/8 of the total distance, right? If you consider this to be 8 for the total there, 5/8 of the total distance is where point P will be, okay? So what do we do with that? Well, the total rise from A to B, well, A starts at 5 and goes to -3, so that rise is -8. The total run from -6 to 2 is +8, right? We're going up by 8 there. And so then to get P's, rise and run, we're going to do 5/8 of both of these values. 5/8 of -8, the rise there, will be -5, P's rise. 5/8 of 8 for the run will then be P's run is 5. So from A, which has coordinates -6, 5, we want to rise -5, taking us to 0 for the y coordinate. And we want to run +5 from -6, so taking us to, oops, that should be a -1 there, my bad. Okay, for the x coordinate. No graphing necessary, but the graph does, I feel like, really help in some situations. Okay, but there it is without graphing. Same kind of idea here, all right? So we're going to go 3/5 of the way for point P. 3 plus 2, 5 total pieces, but 3 of those 5 total pieces in. Excuse me. The rise is going to be, goodness, -15 there total. The runs total is -10. And so then P's rise and P's run will be 3/5 of that -15, which will be -9, and 3/5 of P of the run there of -10, so it'll be -6. So we're going to go down 9 and left 6 from point A. So A, which has coordinates 4, 2, will then be give us P's coordinates here. So let's see, we're going to go down 9 from 2, so it'll have a coordinate -7. And then left 6, so that'll be -2. So -2, -7 is what we would expect there. Okay, questions on any of that? All right. So, well, I guess I could do that. Let me see here. 1 second here. Let me see. Yeah, I'm not going to have us worry about that. Okay, so we've got here a directed line segment, okay, AB. We want to construct the point P that divides a segment in the given ratio from A to B there. Okay, so something that we could do, okay, is we could kind of use our compasses and stuff like that and work from there, but that is a lot of work. If you look here, what we end up doing is like, essentially like taking another array and then making some swipes, 3 swipes for our total there, because there's 2 to 1, so a total of 3 swipes. And then finding the measure of the angle from F to B, and then copying that from at E and D. So it's a lot of angle copies, a lot of work there, and I don't want us to have to worry about that. So instead, we'll cheat, and we'll use our straight edges, okay? And so if we want to find the point P that divides a segment in the given ratio, 2 to 1, that means P will be what fraction of the distance, the total distance from A to B? 2/3, right? If there's 2 parts to 1 part, that means 3 total parts, and we want to go 2/3 of that distance. And so we'll just use our rulers here. We'll measure this distance from A to B. I get the ruler or the measure to be about, I don't know, 3.7, maybe 3.75 even. In fact, I'm going to say 3.75. Okay, it's like halfway between 3.7 and 3.8. And then we'll do 2/3 of that 3.75. Whoops. To get where point P should be, which is 2.5. And then we'll measure from A. We'll measure in 2.5. So 2.5 right there is where point P will be. Oops, not millimeters, centimeters. And I said that was millimeters, that's centimeters too. My bad. Okay? Centimeters. So there it is. So we'll just use our rulers for that. Okay? So let's try one more here, and then I'll get you guys started on your assignment. Okay? We'll do one more here and get you started. All right, so let's take a look at letter B, and we'll just do that one. Okay? So letter B says we want to divide AB so that we have 1 part to 3 parts. So in other words, how many total parts are we going to have? 4, and we're going to go 1/4 of the way from A to B. So we'll measure from A to B there. I get that to be pretty good, pretty close to 5. So I'm going to say that's 5 centimeters. Okay. And then 1/4 of 5 is 1.25. So 1.25, so there's 1.2. There's 1.3, so 1.25 will be halfway between those, so something like right there. And there's where point P will be. There's your 1 part. There are your 2 parts. Okay, just like that. Alrighty, questions on any of that? Okay. Very good. All right, then let me get you guys started on your assignment here then. Okay, so we'll start right there. Okay. I can get you more graph paper too if you run out, or if you'd like some more. I understand that it is helpful to have that graph paper to do these questions and things. Okay, let me tell you here what your assignment will be. Okay, so we're going to start on okay, page 646. Numbers 1 through 7. And then 9 to 15, but those just the odds. And then 19 as well. Okay, so 1 through 7 all, 9 to 15 odds, and then 19 as well. Okay. This concludes the material that we will be testing you on Tuesday. So you might wonder what we're going to do tomorrow. Tomorrow we're going to jump ahead to the next unit, talk a little bit about simplifying square roots. Monday will be review day. Tuesday will be testing. Okay? Because tomorrow is Thursday. It's the end of the week. You guys don't have to finish school on Friday. So that's exciting. Okay, so yes, Steve? Yes, go ahead. I'm going to have more graph paper, like I said, if you need more graph paper.